Hello, and welcome to Redis Security and Redis Security Best Practices. I'm Jamie Scott, the Security and Compliance Manager at Redis Labs. Today, I want to teach you a lot about Redis security, but first, why learn from me? I'm the security expert in this Redis community who's dedicated to ensuring that Redis and Redis Enterprise are secure. I'm one of the few contributors to Redis who doesn't fully understand C, and I live in Santa Clara, California, with my girlfriend, a yappy chihuahua, and a pantry consisting of Red Bull and Red Bull. You can follow me at IamATeapot418 and email me at jamie@redislabs.com. But first, I want to start with a disclaimer. This course won't teach you everything about securing Redis. It's intended to teach you what's practical and prudent, and to help you implement security features within Redis. However, security is an architectural thought process, and no security strategy is going to be complete with only your database in mind. So, hammers don't fix everything. You need a collective toolkit in order to help you implement security as well. So first, let's go through security awareness. We're also going to talk about Redis basic security. Then we'll go into some of the new features in Redis, access control lists, and transport layer security. We're going to round it off by teaching you how to go the extra mile by hardening Redis. Let's start with security awareness. Crypto mining campaigns have been targeting Redis for years, but it hasn't always been practical to stop them. And that's not to say that we haven't tried. Over 75% of open Redis servers have been infected, and the operative word here is open. People are putting Redis open on the public internet without any authentication and without a firewall rule to block them. And this has resulted in many Redis servers being infected. More complex attacks, such as Redis Watermine, have also taken place. Redis Watermine uses Apache struts in order to compromise a server and then attacks Redis, once it already has bash shell into the server. And what this has resulted in is Redis being a prime target for crypto mining campaigns. But it doesn't have to be. In this course, we're going to teach you how to stop that. So it's not only easy for you to find open Redis servers. Free services help you do it. On screen, you can see the service Shodan. Shodan is used to scan the public internet for open ports, and here you can see an example of it doing that for Redis. You can see 2 open Redis servers that we found on the internet. On the far left, you can see it's finding over 13,000 Redis servers on the public internet today. The 2 on screen have no authentication, and you can tell that because you see the info command. But there's more. Redis has implemented several measures to help prevent administrators from these misconfigurations. And these misconfigurations are putting these administrators at risk. We've implemented protected mode, which helps ensure that Redis is only accessible on the local host. We've also implemented auth. Auth is an authentication structure for Redis. Redis also requires a network interface to be bound on the local host only when you use the default Redis account file. You have to actively change all of these configurations in order to open up Redis. The problem we see in the industry is that people are doing this. They're actively disabling all of these security features. However, these are intended to protect you. On screen, you can see Redis in action, helping protect you. This server was open to the public internet, but protected mode is working for them, and ensuring that this user is protected. Now, while they've opened it up to the internet, protected mode ensures that you can only access Redis from the local host. Using a remote service like Shodan, you can't access it, and this is working. So, the security awareness part of this story is that you always want to ensure that Redis is not open to the public internet. If you leave Redis on the internet, you're going to have a bad time. Let's start with some basic Redis security. As I just said, always deploy Redis in a trusted network. This can be a VPC, a VNet, or you're outside of your internal DMZ in a trusted network. This is entirely up to your cloud deployment or your on-premise deployment strategy. However, it should always be done. You should also always use authentication with a strong password. On screen, you can see this strong password in action. We're passing a password to a SHA-512 sum, and then using it to authenticate to Redis. We recommend using a strong password like an 128-character password. This is the maximum threshold that the OWASP Foundation recommends, and it's also something that we stand behind. This helps prevent brute force password attacks, and you should always use a strong and complex password. Let's start with transport layer security. So first, why use TLS? Well, TLS helps protect you against unauthorized access and ensures that only the user who you intend to send data to can access it. It's mandated by many compliance standards, and it helps your customers know that their data is protected. However, it does decrease performance in some instances. However, modern computational infrastructure has been put in place that greatly mitigates this performance degradation. So when should you use TLS? When you process customer information, you should always use TLS if it's sensitive. However, if you're processing funny memes, TLS is probably overkill. And if you're processing legal information, you should always consider the sensitivity. What's important to realize is that TLS is intended to protect sensitive information, and you should always use it with a grain of salt to what information you're passing. And what is TLS really? Well, it's a series of commands back and forth between a server and a client, and this helps exchange protected data. In this process, you can see that TLS ciphers and protocols are being exchanged, asks for certificates are being exchanged before the change cipher spec, which is the flag that says this communication is now encrypted, is actually being put in use. And this demonstrates TLS 1.2. Now, what is Redis implemented for TLS? Before, you always had to use stunnel. An stunnel was an external proxy that had to be configured in order to use TLS with Redis. Now, Redis comes with TLS out of the box. Redis also comes with mutual TLS support. What that means is that certificates now become part of your authentication strategy. You reduce the risk of using a non-trusted server and having that connect to Redis because you know that in order to connect to Redis, you have to have a specific certificate. Redis also comes with TLS 1.3 support, and this is really exciting. This is the latest standard in the industry, and it improves security by implementing more secure ciphers, and it improves the speed of the TLS handshake by removing a full network hop. But what configuration resources do you have? Well, we've created a couple GitHub examples that you can see here, and we've submitted a pull request to the Mozilla SSL configuration generator. This is used by many security professionals to highlight and deploy TLS at scale. And it also helps those who don't understand complex TLS configurations to do this simply. Redis also comes with a TLS markdown file, and this is something that helps us deploy TLS when we don't know how. Now I'd like to get into access control lists. Access control lists are one of the most exciting features that come with Redis 6. But first, why use them? Access control lists really allow you to enhance your operational security within your Redis deployment. You can enhance this operational security and reduce the impact of careless action. Let's take an example. You have two trained administrators, Johnny and Itamar. However, Johnny is still learning. Johnny could be experimenting with a command such as flushdb and accidentally drop the database, whereas Itamar fully understands the extent of those actions. You can reduce the impact of careless actions that way. You can also implement least privilege. Least privilege is the concept that forces you to use only the permissions that are needed to do your job function. Least privilege is required by many compliance and security standards, and access control lists helps you meet them. You also reduce the attack surface by using ACLs. If you are hacked, only the limited subset of commands and command categories that you have given a user access to is accessible to that attacker. You also greatly reduce the risk of a brute force attack by increasing the computational complexity required in a password guessing attack. You now have to guess a username, and this is much harder. While the default user still has the same computational complexity risks, you can easily disable this with ACLs. But what do ACLs do? Well, ACLs implement additional access controls within your database. You now have multiple users, and this can be unique users provisioned for different hosts or user personas. It can also be a different server user for each server that needs to access your Redis database. It's entirely up to you, but it depends on the service. You can also use command and command category level restrictions so that each user only needs access to certain commands, and you only give them that access. You can also restrict access based on the keys that you want each user to have, and this is helpful in establishing least privilege. So what are some use cases? Imagine a pub sub pattern or a streaming pattern. In the streaming pattern example, you ensure that only your producers have the ability to write to the Redis database, while your consumers have the ability to read and acknowledge. You can also have the same thing with an application use case, or multiple applications connecting to one. For example, say you have a primary database, Redis, and several applications that use it. Well, this can help you restrict the access to only what the applications need. You can also now have users here, and you can have privileged and unprivileged users, and users who only need access to a small subset of data. Let's go on. I want to tell you a little bit about the ACL syntax and the ACL command. The ACL setUser command lets you modify user command permissions and set and remove passwords. It also helps you disable and enable accounts and add new users. If I go through the syntax is ACL setUser, the username, the user state, which is on or off, the password, the command and command categories that a user should have access to, and its key restrictions. Command categories are defined by a plus or minus sign and the @ symbol, whereas commands are only defined by the plus or minus sign and the exact command. A password can be passed in clear text or a hash format. You can use the hash sign in order to pass a hashed format password. Key restrictions are established in a glob-style wildcard. Say I wanted to use the namespace secret to establish what keys this user should have access to. Well, I can use secret : star in order to do that. And that way, this user would only have access to keys that had the prefix secret. The ACL dull user command lets you delete users from Redis. Simply put, if you have a user and I want to delete it, I can use ACL dull user and that user's username. You can also view users and their permissions using the ACL list and the ACL get user commands. The ACL get user command gets only one user, whereas ACL list will get every user within the database. You can view categories using ACL cat and view the current user you are running using ACL who am I. If you use ACL cat, you can see a list of all command categories, or you can go deep into a category and see all of the commands assigned to it. And one important thing to note is how you implement key restrictions. The best practice to do this and really help you scale is to design data security labels. Redis access control lists allow a user to facilitate access strategies based on this key design. In a typical Redis key design, you have an object type, an identifier, and a name. Now, you can prefix that with a namespace or data security label. Take this example. We've namespaced this key with the namespace secret, and you can do that for the use case of data classifications. You could also do this many ways, and the use cases are entirely up to you. We're still discovering this because this is a new deployment. We're excited to see where it goes. Now, ACL command restrictions enable operational security as we discussed, but I want to go through a common attack pattern that you would see in Redis. If I were to compromise the Redis default user, for example, first I would check what user I am. I can see here that I'm the default user. I would then set a backdoor using the ACL setUser command. Then I would check for all of the keys in the database. If I could run the keys command, then this would be very easy. Otherwise, I would go with scan, and if both were blocked, I would have a hard time in figuring out what data was on the server. But if I could run this, then I would check the type of each key, and this would allow me to understand what command I should use in order to access it. Then I would be at the goodies of the example and see the actual data. And to err is human, but planning helps, and with operational security designed through ACLs, you can help ensure that you limit an attack. Let's go into a bit of an ACL demo. And here we're going to show ACLs that are misconfigured and don't allow you to pass.
I'd like to start with a short ACL demo. Let's get started by logging in with the Redis CLI. You can see I've set this specific user pattern, and we'll go into that a little bit more later. First, I authenticate with the Redis CLI and clear the screen. Now, I'll authenticate with the default user. The default user, by default, has any password available, and this is defined by the nopass directive. However, I've disabled the default user, so we have to authenticate as an admin user. This is how it would typically be done in a production installation. Let's authenticate as an admin. Okay. Then do an ACL list command. ACL list shows you all of the users in the Redis database. The admin user has access to list users within the Redis database, and as you can see, they're all protected by hashes. Commands can be restricted using the plus or minus operator as part of the ACL command. Categories of commands, such as read, write, or admin, are denoted with the @ sign. You can see in the admin's user permission, the @admin category of commands, and this is given to the user so that they can have admin level commands. If I wanted to set a new user, I could use the ACL set user command. Let's do that with ACL set user and set a user Itamar. We're going to turn the user Itamar on and give him the password. He then gets access to plus, set, and hgetall. These are the only commands that Itamar will be able to access. We'll also give Itamar access to every key, and that's as easy as it is to set up a user. Now, I want to start with a short demonstration, and to do that, let's start with a scan. So let's scan all of the keys within the database. And you can see this admin user only has access to administrative level commands, and because of that, he doesn't have access to scan. Now, the default user is turned off and has full permissions. What we're going to do is turn the default user back on, just for purposes of this demonstration. This should never be done in production. ACL set user, default on, will do this. And then we authenticate to the default user. Now, it's important to note the default user, as you can see here, has no pass. And what that means is that the default user has any password allowed. We can just type in N, and we're automatically authenticated. Then we're going to issue scan again, and this time we're going to scan the first 20 keys. You can see that these keys have many different namespaces. We have the top secret namespace, the public namespace, and the secret namespace. Each one of these is going to be accessible by a different user on the database. Let's observe this in action. First, I want to authenticate to the service account user. Then we can do hget of secret user 16. The service account user has access to the hget command and has access to the secrets namespace. You can see that with the command I've pasted here. Now let's try to hget but access the public namespace. And you can see here that this is different. And this is different not just because I forgot a small portion of the command, but you can see here that the user doesn't have access to the public namespace. And because of this, he doesn't have access to the keys that's needed to access this. Now let's switch users. Let's change our user to the user 1. And this user has access to the hget command and the public namespace. You can now see here that the item is a table. And if we were to now set this item to a pumpkin, you can see that we no longer have this access. And that's not because we don't have access to the key. It's because we don't have access to the command hset. ACLs helps you implement the most granular levels of security, and your application can do this too. We're excited to see the practical use cases to come.
Now that we've completed our ACL demo, it's your turn. I want you to pause the screen and complete this exercise. First, I want you to create a key with the name secret password and another key with the name public username. You can see here that we're namespacing as we've discussed earlier. Then I want you to create any user with access to these keys and only access to the set command. Then I want you to create another user with access to the other key, but with only access to the get command. Then attempt to access both keys with both users and see what you can do. Pause your video now, and then we'll review. So, how did it go? I'm really excited that you tried this because now you can see how to implement ACLs firsthand. Let's review. First, you're setting the key, secret password, to a specific password. And then you're setting the key public username to Jamie. Then you create two users. You could have also done this by using get and set, but you could have also done this with a read and write category. And we've restricted to a namespace keys pattern to help show this. First, you authenticate to Jamie. Jamie has access to set commands, so this is our write user. But you can see they can't read, but they can write. If we switch to Kenny, this is the opposite. Kenny can write, but he can't read. Let's go over some command categories. Redis comes with out-of-the-box command categories that you decide what permissions to give. Categories are based on several structures. First, you have the data structure type. You also have the performance profile. You can tell whether a command is administrative, blocking, key space command, or a transactional command. I want to spend a little bit more time on dangerous though. You were probably alarmed when you saw dangerous, and especially when I skipped over it. But I want to give you some assurances here. Dangerous commands don't always have to be dangerous. Dangerous commands sound scary, but they don't have to be. Administrative commands are always marked as dangerous, even if they're not. Take the example last save. Last save just shows you the timestamp that Redis was last persisted to disk, and this helps in persistence strategies. But this is simply just a timestamp return command, and isn't dangerous at all. It's only marked as dangerous because it is administrative. Replica of, on the other hand, could be used to create an authorized or unauthorized replica, and this should be monitored for specific uses. Dangerous commands could also impact availability. The shutdown command, flushdb command, and flushall command are examples of this. Dangerous commands also may impact performance, and like you've probably heard preached hundreds of times during this conference, don't use the keys command in production. It can really hurt your performance. I also want to go through the ACL log command. The ACL log command helps you troubleshoot ACL failures. ACL failures could be caused by authentication failures, blocked keys from being accessed by key restrictions, or blocked commands that a user couldn't access because of a command restriction. Let's lock down the ACL log output. You can see here, one command was blocked, and the command that was blocked was the set command. Jamie was the user who was blocked, and you can see exactly when this occurred. You can also see the connection info for Jamie, and this helps you with troubleshooting. ACL log's practical use case is to help you troubleshoot a troublesome application. This will show you exactly what is being blocked by your ACLs, and can help you fix your application in the long term. Now that we've completed your demo, we want it to be your turn. Please pause the video and take 5 minutes to complete this exercise. Here, I want you to create a user with +@read and +@admin permissions. Create another user with +@write permissions, then create two keys as strings. Set a key and get a key with both users, and then view the ACL log for these failure events. These will help you troubleshoot these permissions and where you went wrong.
Now that we've completed the exercise, it's time to review. First, we create two users, the user Jamie and the user Kenny. We give them both the password and turn them on. Jamie is given read-only permissions, and Jamie is given administrative permissions. Kenny is given write-only permissions. Both users are given access to every key in the database. Then, we set two keys, the key foo and the key bar. Authenticating as Jamie, you can not write to the key bar. You can see this by the fact that Jamie is blocked. But you can read the key, and this is because Jamie has read-only access. Authenticating to Kenny, you can see that Kenny can't read the key, but Kenny can write to the key. Kenny changes this key here. Authenticating as Jamie, because you have administrative access, you can use ACL log. The ACL command is an administrative category command. You can use this in order to troubleshoot why these commands failed. If this were an application, you could use this to see what was wrong with your code and assign the appropriate permissions. Now I want to take a moment to discuss going the extra mile with Redis security. Going the extra mile involves hardening, and there's 4 practical steps that you can take. You can change the Redis port, you can disable the default user, you can rename commands, and you can ensure Redis is up to date with the latest security patches. Hardening Redis can help you ensure that you reduce the attack surface area, and not all steps may be appropriate for your use case. Let's discuss changing the default port. Changing a default port is never going to actually protect you, but what it does is prevent scripts from attacking you using common scanning techniques. Many of the attacks, such as Redis WannaMine earlier, use these common scanning techniques. Redis WannaMine, for example, is actually using the Apache Struts vulnerability. Once it exploits it, it's going through and scanning the Redis default port and trying to authenticate against the default port using common passwords or no authentication at all. Changing the default port in some of these examples would have actually blocked this attack because the script being used wouldn't have executed against any non-standard port. Disabling the default user, as we discussed earlier, can greatly decrease your risk of a brute force attack. This helps you to ensure that someone always has to guess a username, and this increases the computational complexity of brute force attacks, making them exponentially harder to execute. You can also rename commands, and what this does at a practical level is globally disable commands. Now, you can rename them into something and prevent users who don't know the new name from using it, but this is practically demonstrated by people using ACLs. ACLs deprecate this. Ensuring Redis is up to date is always something that you should be doing. Take advantage of the latest security patches. They're there for you. Now, I want to take a moment to go into an attack pattern that many people wouldn't think about. Many people think of databases and they think of injection as a common attack. An injection, as a traditional sense, doesn't apply to Redis. That's because Redis doesn't have an escape character. It is command-based and not query-based. However, there is a business logic injection that could take place. Let's pretend we're an e-commerce site, for example. Here is a basic API design and how that API would interact with Redis. You have 2 APIs, a price API and a discount API. You can see here at the top, you give a discount of $100 every time you call the discount API. However, if you change the price API to go directly to the discount, you could get a negative $100 price. Now, that sounds like the price of oil recently, and that's terrifying. Always ensure that your key structure is designed to ensure that injection can't take place. And as a mitigating control, what you can do is validate against the colon command here. Your spacing character is an easy way for you to do input validation to prevent business logic flaws. Now that we're complete, I really want to take a moment to talk to you about how Redis Enterprise can help you secure Redis. The value proposition of Redis Enterprise for security is that it helps you simplify securing Redis. We've talked about a lot of these things. Redis Enterprise helps you randomly assign a default port. You don't use 6379 with Redis or Redis Enterprise Cloud for Redis Enterprise. You use a randomly assigned port. You can also configure a user through the user interface. Having a unique user interface helps simplify this for enterprise use cases. Redis Enterprise also blocks some commands by default, which can prevent common attack patterns. In Redis Enterprise Cloud, you're forced to always use a password. We've also implemented automated VPC peering, and we manage the operating system for you so that you can focus more on delivering business value instead of managing an operating system and securing your database. Hey, I really appreciate you taking the time to learn how to secure Redis. We see Redis, ACLs, and TLS being a huge value add for the security community and the Redis community as a whole. Thanks for your time listening to this today. Best of luck in the rest of RedisConf.